Hello, welcome to see you on my tutorial for PGP KeyServer caches. Why do we need them? What's interesting with this? And why you should do it? This is what we are talking about now. What we want to do today is we want to see what's a PGP KeyServer, so in basic and principle, and the PGP KeyServer implementations. So the good and the bad thing, a bit about the history. But the most important thing is, why do I need it for true DevSecOps? What can I do with this, or what's the point of having one of these, and how to install and start it. So, what's a PGP KeyServer? Well, a PGP KeyServer is a repository for public keys. Public keys means it's this part of the key ring that it can distribute freely, so that everybody else in the world can get this one and verify if, for example, something is signed with your private key. So for this you need this one. It's a central database for public keys, and it's free distributable. The main thing is everybody can add a new public key to this key server. And one important thing here is to know you can't delete a key here. Keys can only be invalidated. The main point for this is, even if you say this key is not valid anymore, you need the information this key was used once. You can verify for the history it was a valid key from the point of time A to B in the history. And yeah, that's more or less, so that you have the information this key is invalidated. Even this is an information that you need to know, and this must be stored at public key servers. So even deprecated keys, they must be available, and it's no way around to delete it. So you need it for the history or for the future. So if you have this key database, you have different implementations that you can use to ramp up your own PGP KeyServer or KeyServer cache. There is an old reference implementation called SKS, and it's a single threaded one. It's written in OCaml. I know not even one developer that's able to develop this one, and this is that they had a decreasing community, because this was not a fancy project. It was not written in a language that people enjoy, and it's not a big use cases handling of these keys. So it's more or less deprecated for public usage. But why? The main thing here is this key server reference implementation was used a long time for the public key servers as well, the official reference public key server. And based on the fact that you can just add keys, was used by some people to just push millions of useless keys there because they don't like the concept, they just want to destroy something, whatever. They just added a huge amount of useless and not usable keys, and this was bad. So they decided that they need a new one, because this conceptual weakness. They couldn't get rid of it. So they spammed by useless keys. They must have found a way around to have barriers. So on one way that the adding a key is simple and possible for everybody as well, but to make sure that the spamming of keys is a little bit flattened down, so that's not so heavily done. And there was some issues with the data protection. Well, this is a conceptual thing, because all email addresses that are in this public key databases can be used for spamming again. So you're just downloading this database, extracting all email addresses, and use this as a spam list. So these are some points that are not so nice from the concept here, but the main thing is it's a strong monotonic growing database, and they had to stop this one, and for this they needed a new reference implementation. The new reference implementation, I think the project name is Hagrid. It added some workflows for adding keys. Here in general it's more or less the point that earlier, or in the old days, you could just upload a key. Now you have to upload a key, you will get a verification email, you have to verify that you are the owner of this email address, and then you can add one. I'm not sure if they put some delay in it just to make sure that it's not misused or whatever. But this is a new reference implementation, and you can install it, it's open source and so on. So everything's fine. But why do I need this caching key servers for DevSecOps inside my company? So inside the company you have, for example, the need to install. For example, you have this Linux installation and you want to install Docker. You're adding a dedicated Docker repository and a Debian repository where you can download the Debian packages to install Docker. So, and at this point, Debian is asking for this key with a fingerprint to verify that this package is a valid one. What you can do is you can just add this key on every machine to the key ring, or you can have an internal key server that you are asking to verify this fingerprint that's requested. So if you have a high security network or you don't have a permanent internet connection, then you can just use this internal cache to make sure that everything is running in a way it's expected. And the good thing is that this key server database is not big, so I mean it's we are talking about a few gigabytes, but more or less this one is one of the important things. So you must be independent from external resources. So even if your internet connection is not available or the service you are constantly asking or normally asking is down, it shouldn't slow down your production. So being independent from external resources means that even validating these keys must be independent, and for this you need one of these caching servers. Reproducible installations means if you have an installation on Docker image created or whatever done, and you have to analyze later why things happened or what was the base for the decision, it must be in a way that you can reproduce old situations again. And for this, caching also keys you have is one way to go. It's one part of it. You can use this internal key server for exchanging internal machine-to-machine keys if you want to use this public-private key mechanism somewhere and you don't want to push these keys to external key servers. You just want to use them inside for verification process or whatever, then you can use this internal caching key servers as well, because the machines are just using this one instead of the external one. And on-prem or for high security networks, sometimes you don't have an internet connection, then it's easy to have an internal caching key server and just asking this one with an official snapshot that is coming in on a regular basis. So if you want to have more information how this feeds in DevSecOps or DevSecOps in general, just go to my DevSecOps tutorials and have a look there. And now we know that we could need this installation, so how to install and start it. There are a few things that are worth for mentioning. So one thing is an apt-get install SKS is just enough to install this one. So if you want to have it in a high security network again, just use an Artifactory Debian repository as a proxy, and X-Ray can scan all binaries so that you're making sure that you don't have compromised installation. But after you install this on a Linux machine, just create an initial database, and if you have this initial empty database, you need this import dump or this dump to import. So the official key servers, with the new or the old implementation running, don't care, they are using the same export format for the key database. They are normally exporting this key or the whole database every day at least once. That means based on this you can just download on an external machine on a regular basis, dump, take this one into your high security network and import it, and then you have a very actual snapshot that you can use and verify internally. And the last step is just testing the server. These command line steps for using, importing a database and merging it into and all this stuff, just read my corresponding blog post for this one here, and there you will find step-by-step install instruction and commands for importing all this stuff and get it run. In summary, what we had is we have a very easy to install and an easy to maintain cache for the keys. With this, you are completely independent from the outside world with your processes, with verifying keys, handling such verification processes. And the good thing is you can use this internal key server for managing your temporarily machine keys if you want to have this technique used. The hardware requirements for the old SKS key server implementation is just one CPU and 2 GB of RAM, I think, and a little bit more than 30 gig for the database and the operating system. So it's really a small machine compared to other requirements from other systems. And so you can use the old reference implementation. The only thing is, don't use this old reference implementation for the outside world. So don't make them public, just use them internally, then it's fine. If you want to go to the public or to the open world, just use the new version, the hybrid one. The installation is a little bit more tricky. You have a bigger workflow to deal with. So this machine-to-machine workflow is just more complicated to implement. So I would really recommend use the old implementation inside your closed networks or your on-prem installations, but never make them public available. X-Ray can scan all these binaries to make sure that you don't have an invalid or uncompromised version of SKS. So if you want to have more information about DevSecOps and X-Ray in general, just check out my X-Ray tutorials at this point. And last but not least, if you have even the PGP key caching server internally, all steps of all installations and runtime binaries and all this stuff, they are reproducible because you are completely independent from the outside world and everything is under control. So this is the main point why it makes sense to use an SKS key server inside your own network, even if it is an old legacy implementation, but it will give you a lot of stuff that is nice and can help you very good. If you want to try it out, how to deal with this Debian repositories and integrate this one in your process, just go to jfrog.com/platform/free-trial and build up your JFrog platform on cloud or on-prem and just play around and test how this could help you and add the SKS key server to this implementation. Okay, that's it. Thank you very much for reaching out me at this short tutorial or short talk. I'm available via Twitter or via email. If you have any questions, just ping me or write me a message. I'm more than happy to have a discussion with you. And well, otherwise, enjoy the rest of the day and see you later.